Let's start now with chapter 11, lesson 2, which is talking about probability. But before starting our lesson, let's revise the, here now. Now, as we know, if we have like a dice, okay, or a cube with 6 numbers, we know that we have it has 6 faces, 1, 2, 3, 4, 5, and 6. So the dice or the cubes, it has 6 faces. So each one has a number. Now, if I'm asking you now, what is the probability of getting number 1? What is the definition of the probability? What is the probability?
How much can
times that event occurs over the number of trials?
Yes, also you can tell me. It is how
happening?
How likely something is to happen.
Yes. Now, to find the probability, I'll write the number of events over the number of trials. Now here, how many outcomes we have?
For number 1, we only have 1.
You have no. I mean, how many outcomes for the trial? How many outcomes we have? We have 6 outcomes. Okay, but how many? How many number can I? Or how many events can I get number 1?
1.
1. So I will say here the probability of getting 1 is 1/6. Probability of getting 5. How many 5 here in the dice?
1.
1 also. Over 6 possible outcomes. How many? What is the probability of getting number 3 as an example?
1.
Also 1/6.
Also, since I have only 1, so I will say 1/6. Now all of these probabilities, I will call them equally likely, because any of these numbers have the same opportunity or the same chance to happen, or the same probability to happen. If you choose 1 or 2 or any number, its probability to get it is 1/6. Now, what if you have now?
Because it is not repeated, right?
Sorry?
Because it is not repeated. They all happens at once.
Yes, it's I have only 1 number here. I have only 1 5. I don't have 2 5s. I have only 1 5, so I will say it is equally likely. If all the events have the same number of probability, I will say they are equally likely. Now, if I'm asking you now, what is the probability of getting number 7? What did you tell me?
It's impossible.
It is, there's no 7 here. So I will say it is 0/7, which is 0. This type of probability, I will call it impossible probability. It cannot happen. Now, if tell you now what is the probability of getting natural number?
I think also natural number over 7. Any natural number over 7.
How many natural numbers here?
6. So 6/7.
You have 6, yes. So I will say I have 6. How many possible outcomes?
Can be,
6.
Also 6, which is 1. This type of probability, I will call it certain probability. So the impossible probability is 0. The certain probability, it must happen. It surely will happen. It have 100 opportunity to happen. We call that certain probability. So I have 3 types. Impossible probability, it have 0 chance to happen. We have certain probability, it has a 100 chance to happen. And we have at any probability it's a chance to happen between 0 and 1. Like what did we see before? 1/6. This is a probability. So here we can say now that if I have a 0, sometimes I have probability equals 0, probability is less than 1, and probability equal 1. If the probability equals 0, I called it an impossible. If it is between the probability between 0 and 1, it is a equally, or it is any probability. And if it is equal 1, we called it certain probability. Now be careful, the probability cannot be greater than 1. Don't tell me later on, sometimes I found some mistakes with the previous classes. After the solving, they told me, teacher, the probability is 1.63. This is false. The probability cannot be greater than 1. It must be 0.4, 0.7, 0.73. It must be less than 1, and it cannot be negative number. It cannot be -4. It is also false. Okay? Okay. Let's have another example now. If you have now, like also numbers like 1, 2, 3, 4, 5, and 6. So the same example. Here you have the dice. It has 6 faces. Each one has a number. Now, and 7 also. Let's add number 7. Now, what is the probability of getting odd number?
4/6.
Oh, before that, no, I will remove 7 now. What is the probability of getting 1? As we said before, it is 1/6. What is the probability of getting odd number?
3.
How many odd numbers here we have?
3.
1, 3, and 5. So I have 3 numbers are odd over 6 outcomes in the event. So I will say 3/6 or 1/2.
1/2.
What is the probability now of getting even number?
Also 3/6, which is 1/2.
Look here, we have 2, we have 4, we have 6. So we have 3 numbers over 6, which is 1/2. Are the probability of getting odd number and even number are equally likely?
Yeah.
So they are equally likely. Now, how can we have a probability, but it's not equally likely?
By
Let's
adding
have an
7.
example. Yeah, exactly. Let's have here like 1, 2. Let's have as an example 5, 6, and 7. Imagine now you have 7 cards. Each one have a number 1, 2, 3, 4, 5, 6, and 7. Now, I'm asking you now, what is the probability of getting odd number?
4/7.
4/7.
How many odd number here we have? We have 1, 3, 5, and 7. So we have 4/7. What is the probability now of getting even number?
3/7.
3/7, yeah. Now, are they equally likely?
No.
So this type of probability, I will say they are not equally likely.
Teacher, they should be equal or no?
Sorry?
Like they should be equal when solving the question and like that, or no?
They should be equal?
Yeah.
Yeah, I mean like 3/7, or like 3/6, 3/6. 4/6, 4/6. Like this. They have the same number. Let's start now our lesson. This is just a revision. So what is the probability? In this lesson, we will learn how can we find the probability for an event using theoretical and experimental. Now, the probability measures how likely it is for an event to occur. How likely the event will occur. Now, as I told you here, the probability of the impossible event is 0. The probability of certain is 1. Otherwise, the probability of an event is a number between 0 and 1, or a percent between 0% and 100%. When you gather data from observation, you can calculate an experimental probability. Each observation is an experiment. Now here, as I told you, we talk about theoretical and experimental. Experimental, like you gather data, you make an experiment, you make an observation survey, you get this data, and then you will find its probability. That's why we call it experimental, because you make an experiment. Theoretical, no. It has a number, it has a certain number, it has a fixed numbers. You will find its probability. Experimental, you did an experiment, like you bring a coin and you test it 5 times. Maybe you get 2 hit, 3 trials. Other one get 1 hit, 4 trials. So that's why here I will say that it is an experimental, it's not a theoretical. So the experimental probability is number of times the event occur over the number of trials. So it is the number of times of the event over the number of the whole trials. I toss a coin 10 times, but 3 of them are head. So how many trials should I make the event? I make it 10 times. But if I'm asking you what is the probability of getting head of the coin, you tell me how many times of head. I tell you 3. So you will tell me now it's 3/10. So it is the number of times of the event to occur over the number of trials. Let's have now this example here. Of the 60 vehicles in a teacher's parking lot today, 15 are pickup trucks. So here now, what is the event? What is the event? The number of what?
The number of vehicles.
The number of vehicles. This is an. Who's Muhammad Ahmed?
I think that's Lama.
Lana.
Lama.
Okay. I know. Thank you. So here we have, now let's come back. Here we have to find the experimental probability. We have 60 vehicles in a teacher's parking. 15 of them are trucks. And they asked me what is the experimental probability that a vehicle is in the lot is a pickup truck. Now here, what is here, as I told you before, it is a number of event over number of trials. The probability is number of event over the number of trucks, trials. Number of events over the number of trials. Now, here, what is a trial?
60.
60.
Yeah, it is selecting a vehicle. So it is a 60. So a trials here is selecting a vehicle. Now, what is the event here?
15.
It's 15.
Yeah, it's yeah, and that's me. Select a truck. So let's find the probability now. The probability now of the pickup truck, the probability now of this event to occur is the number of the trucks, which is 15, over the number of the vehicles, which is 16. So 15 over 60 over 3 is 5, over 3 is 20, over 5 is 1, over 5 is 4. So it is 1 over 4, or I can say it is 0.25. This is the probability of getting 15 trucks from the whole vehicles. Now, let's have another example. A softball player got a hit in 20 of her last 50 times at bat. What is the experimental probability that she will get a hit in her next at bat? Here now, how many trials we have?
15.
50.
So the probability of getting a hit. How many trials we have? We have 50. How many times will the events of getting a hit will occur? 20. Exactly. So I will say now they are 2 over 5 or 0.4. Look at it here. It is less than 1. So it's correct. This is how we find the probability. I will ask myself how many events, how many trials. I will divide the number of events over the number of trials. Now, what is the meaning or why we use or why we get these numbers? Now, all of us know that in any newborn, when the mom gets pregnant, we can have a boy or we can have a girl. Either boy or girl. So, what is the chance of getting boy?
1.
1. How many trials we have, possible outcomes we have? 2.
2.
So I will say the probability of getting a boy is half, and the probability of getting a girl is also half, and they are equally likely. What does it mean? What does it mean, this half? Help me. What does it mean? That means if I am pregnant, I have a chance or probability of half to getting a boy. That's helped me that you can have a boy or a girl. I mean, if I am getting pregnant, I have a probability of half to get a boy. In this girl here, the softball player, when she getting 20 over 50, look at the question here. He asked you about what is the probability that she will get a hit in her next at bat. Here probability is 0.4. That's mean if she repeated 100 times, she will get approximately 40 over 100. That's mean if she make it 100 trials, 40 of them will be hit. Will be hit, yes. Okay. As an example, I am every time I get in the quiz, like, no, not in the quiz. Give you another example. Like, as an example, I make a quiz for you in the class. Most of you are 10 girls in the class. 7 of you get full marks. So I will expect later on the second quiz that I can have the same number of girls or less than or greater than to get a 10, to get a full mark. So I can have like an expectation to know that on the next quiz, how many girls will get full mark. This is the meaning of probability. Another example, in the soccer team or the football team, we know that we have three, in the trial, we have three things may happen. They will win, they will lose, or they will get the same number of hits. So if she win, I will say they are 1/3. If they are lost, I will say 1/3. If they have the same number of hits with the other team, I will say also 1/3. If they make 20 matches and 5 from them are winning matching, they are win in this 5, or they have a 25 of them, they are winning. So if they make a 100, so what does it mean? They can expect later on that our probability to win is 1/4. That's mean if they made a 100 match, multiplying by the probability of win, they will accept that they have a 20 matches
25?
to win. At 25, sorry. 25 to win from 100. Is it clear?
Yes.
Teacher, and if
Yes.
they are, for example, 50, if they are 50, there will be 12.5 chances, right?
50 trials, you mean? You
Like,
have to
for
multiply here
example,
by
instead
2.5.
of,
Yeah, you multiply
yeah.
1/4 by 25.
Okay.
Now, a class tossed coins and recorded 161 heads and 179 tails. What is the experimental probability of heads of tails? Before that, if I told you that I have a coin, I toss a coin and I get 4 heads and 7 tails. Who can Who can tell me how many times did I toss the coin? 11. Thank you. I make it. I toss it 11 times. 4 of them are head, 7 of them are tails. Here also we have the same, but with big numbers. They toss it. They record a 161 head and 179 tails. What is the experimental probability of getting head? Now, how many times how many trials we have here?
300.
I will add, that's mean I will add 161 plus 179.
Which is 340.
6 plus 7, 12, 30 here. So it's a 330.
Teacher, no, it's 340.
Not 40.
6 plus 7, 30, 40, okay. So it's a 340. This is the number of trials. Now, how many times of event or getting head will occur? 161. Now, what is the probability of getting tail?
179 over 340.
179 over 340. Is it clear?
Yes.
Yes.
Yeah.
Okay. Now, the set of all possible outcomes to an experiment or activity is a sample space. The set of all possible outcomes, we call it sample space. When each outcome in a sample space has the same chance of occurring, the outcomes are equally likely outcomes, as we said before. So the set of all possible outcomes, we call them sample space. Like this one here, we have a big circle, we called it sample space. It's a set of all possible outcomes. Like I have a dice, I can have 1, 2, 3, 4, 5, 6. These are the outcomes. Or if I toss a coin, all the outcomes. It could be head or tail. These are, we call them the sample or the sample space. Now, for one row of standard number cube, there are 6 equally likely outcomes. So you can calculate a theoretical probability as a ratio of outcomes. Without just in the first one, as I told you, a class toss a coin. The softball player. So they are experimentally. I make an observation, I get a data to find the experimental probability. Here I'm talking about theoretical probability. Like I have a dice, I have a 6 cube. So the only outcomes I have 1, 2, 3, 4, 5, and 6. Let's talk about now the theoretical probability. If a sample space has n equally likely outcomes and an event A occurs in m of these outcomes, so if the sample space have n outcomes, they have a number of outcomes, and the event A, it has a number m of outcomes. So I would say that the theoretical probability of get event A is how many outcomes for event A? Let's name it with m. And how many outcomes for the sample space for the set of all the possible outcomes? We name it with n. So the probability of getting A is m over n. The number of the outcomes of the event over the number of the outcomes of the sample space.
Are they both the same?
Sorry?
Like, what is the difference between experimental and theoretical?
Experimental, that I make an observation. I make the experimental. I make an observation, like I toss a coin.
Oh yeah, and after that, in the theoretical,
you will collect a data, you will count, you will find the probability. Here it is theoretical. It's not happening.
Yes,
It's theoretical. That's mean if I make it, or Rose, or Lama, or Lana, or Haneen, or anyone, they will get the same number of probability. Because if I'm asking you how many numbers of getting 1, you will tell me 1 over 6. But in experimentally, like if I make just a coin 10 times, I get 3 of them head and 7 tails. But Haneen may get 5 head, 5 tails. Ragad may get 7 head, 3 tails. That's why they are experimentally probability.
So theoretical probability are always equally likely outcomes?
No, that doesn't mean all equally. I mean like they have the same number. And they are equally likely. Okay, yeah. Sometimes in the experimental, you will find equally likely.
Okay.
But it is theoretical. Do you mean what's the meaning of theoretical? It's not happen.
Yes, yes, okay, teacher.
And I mean, I didn't you make an experiment, I will count, you will count. No, you have a theoretical numbers, and I'm asking you how many numbers of getting odd. In experimental, you will test how you roll a dice to tell me how many even numbers you get. But in theoretical, you just look at the numbers, you can't tell me how many even numbers you have without making an experiment.
Okay. Okay, thank you, teacher.
You are welcome. Now, finding a theoretical probability. What is the theoretical probability of each event? Here now, as you see in this picture here, we have 6. Here we have a dice or a 6 cube or number cube. And you see, as you see here, we have 1, 2, 3, 4, 5, 6 points on each face. Now, what is the probability of getting a 5 on a one roll of standard number cube?
1/6.
1/6.
I have how many? Now, what is the sample space here?
6.
6.
Yeah, the sample space is getting 1 or 2 or 3 or 4 or 5 or 6. So I have 6. Yeah. Now, what is the numbers of the possible for the events, for the outcomes for the event? I have
1.
only 1. So I will say it is 1/6. Why 1? Sometimes, teacher, why it is not 5? I'm asking you not what is the number, how many 5 in the number cube. You tell me only I have 1 5. So that's why I write it as 1/6. Now, the second one, getting a sum of 5 on one roll of 2 standard number cube. Now here, in this example here now, we have 2 number cubes. So, since we have 2 number cubes, how many possible outcomes we have?
4.
If we have 2 cubes.
Here we have 2 standard number cubes. I mean, I have this one, and they have another one.
Is it 4?
So 6 times 6.
It will be 6 times 6, exactly. This is like for the counting method. Here I have 6 times 6. So if I have 2 standard cubes, that means I have 36 possible outcomes for the sample space. Now, but what is the question? The question is getting a sum of 5. What does it mean? That means if you toss or if you're rolling the number cube here, I will ask you now. You know that you have 1, 2, 3, 4, 5, and 6. And in the other one, we have 1, 2, 3, 4, 5, and 6. Now I want you to give me the numbers of getting 5. If the 2 numbers, 1 from the red and 1 from the blue, if you add them, you get 5. 1 from the first cube and 1 from the second cube. If you add them, you get 5. Here we have 1 and 4, 2 and 3, 4 and 1,
And 3 and 2.
And now don't say, teacher, I write it 1 as 4, 1 and 4. No, 1 and 4, that's mean 1 from the red cube and 4 from the blue cube. But 4 and 1, it's mean 4 from the red cube and 1 from the blue. So they are different. 2 and 3, here is the red, and here is down, we have a blue. So 2 and 3, that's mean 2 from the red and 3 from the blue. But if you say now 3 and 2, that's mean 3 from the red and 2 from the blue, and they are different.